Hello, good morning everyone. Welcome once again to OrderCon 22. I'm Chandrasekhar. I'm part of the engineering team at Sedai. So I'm part of the team which focuses on the Kubernetes solutions in Sedai. In the past few years, we have seen a huge increase in adoption for Kubernetes. Kubernetes is an excellent platform which provides you with all the facilities to fine tune your application and run it the way you need. We at Sedai use Kubernetes for deploying our applications along with serverless and some other managed services from AWS. So one question that we get a lot is there a need for another system or an autonomous system to manage Kubernetes? So Kubernetes is in fact a declarative system, an excellent one where you can specify the needs of running your application and Kubernetes will take care of the rest. But in fact, it is actually giving you all the bells and whistles required for its users to customize and fine tune the way you need to use Kubernetes. So effectively, Kubernetes is actually giving all the responsibilities for utilizing it to the users themselves. So in general, if there is a cluster with around like 100 microservices with approximately 2 weeks release cycle, you're looking at around 18,000 different variable combinations to make sure you're running the applications in the best possible way and at the best cost benefit that you need. This is almost impossible to be handled on a manual way. If you have listened to the previous presentations about the autoscalers, you know what all combinations are going to be available there. And if you get any of those ones incorrect, you're going to have a big negative impact on the availability or on the performance. So in general, when you're trying to make sure you're running Kubernetes in the best possible way, your high-level goals are making sure your applications are running at a very high availability and you're running your applications with good performance the way you need it and minimizing the cost of your whole cluster. So the natural solution for this is actually to use autoscalers. So we already saw how you can utilize HPA, VPA to autoscale your application. And to utilize that at a cluster level, you need to have some kind of a cluster level autoscaler. And the way you go about doing it is by looking at the resource usage from the application, checking the application behavior, coming up with thresholds, and at a pod level autoscaler, there are different ways of handling it, but most of the autoscalers look at unscheduled request. You look at the application requirement and try to supplement with the infrastructure. Now, let's see if we can automate this one. What are the steps needed to actually automate and make sure your Kubernetes is running at the right possible way? So usually, as a first step, when we pick something for automation, there are a few things that we look at, the attributes where you choose candidates for automation. So usually those are repetitive tasks, which are really tedious, time consuming, and naturally it is going to be error prone. And most importantly, these are tasks that does not change. So once you set it up, you don't need to actually worry about it at all. It just keeps on doing as clockwork. So some of the common examples that we have seen is automation of bills, CI/CDs, some level of testing can be automated. So let's see how or what are the aspects that you need to look into to automate Kubernetes to make sure that you have the highest possible availability and in an optimal way. So just expanding on the attributes that we discussed, the first thing that you want to look at is application behavior. So the way you get insights into the way application is working is by looking into the metrics. Next thing is you have to figure out what is the right threshold for all these outcomes from the metrics that you're seeing. Based on these thresholds, you need to adjust the pods, increase the pods if you need more resources for an application, or reduce it if you don't need it. And at the cluster level, you need to actually change the infrastructure which is backing the whole request from applications. Now, if whatever you're getting out of Kubernetes is not enough, sometimes you probably might want to go with scripted remediations. And that is where you look at attributes and try to do some kind of custom remediation. And of course, you probably want to have some kind of a notification so that people or some humans are aware of what is going on in the system. Okay, now let's a little bit deep onto how we can achieve this one. So the first thing, when we are observing metrics, we have to figure out what is the right metrics to observe. So if you have attended the first session which talked about picking up the right metrics, not every application behave the same. And there are no standard metric which work for all applications. So for example, there could be applications where you can infer the behavior just by looking at the saturation metric, CPU or memory. But not all applications work the same way. You could have an application where your performance is super critical and you're probably not too much concerned about your resource usage. You want to just make sure that application works very well. In ideal conditions, they might align very well. Your performance and CPU might align very well, but it is not always guaranteed. There could be other factors. So for example, there could be applications which is highly dependent on the network usage or IOPS. So there are so many other attributes which could be critical for applications. And the next thing is, once you've figured out what is the right metrics which indicates an application behavior, the next thing is figuring out the right threshold. So even if there are two applications which uses the same metric, it doesn't mean that both of them behave the same way. Each application could have thresholds of the performance slightly different. And when it comes to the cluster optimization, you're actually supplying nodes to actually meet your resource requests. There could be different type of application. You're most likely your Kubernetes cluster is going to run heterogeneous workloads. So the requirement for application A could be totally different from another application. One could be CPU intensive, one could be memory intensive. So you have to determine how do you supplement, what is the right type of node to actually supply to your cluster so that it performs well and maintains the lowest cost possible. And when it comes to the remediations, usually we can't find like a one fix which just works for all the situations and for all the applications. So a lot of times you probably need to have a slightly different fix depending on the situation. And then again, we are actually not trying to figure out the bug and fix it on the runtime. We're just trying to make sure your applications are running well in a given situation. And the last thing is, when you're looking at the notifications, you have to make sure that you notify at the right time. If you actually send too much notifications, then it's quite possible that people start overlooking those notifications. And if you don't send enough notifications when it is really required, then you might run into availability issues. Now, if you look at it, this problem that we are dealing with can be kind of translated into a mathematical problem of optimization, where you have a bunch of constraints and you have a set of variables that you can actually adjust so that you meet the constraints. So in this case, the constraint is of course going to be the cost, making sure that you don't overspend. And at the same time, we get the performance which is required by an application. And in some cases, there could be applications which has very strict SLAs. And now let's look at the variables, how we can achieve that one. So we already talked about HP and VPA. So if you need to configure HP and VPA, we have to actually figure out what is the right metrics and right threshold for the configuration. Now, traffic is another one. If you've attended the previous sessions again, you already saw how traffic could impact your application performance. So the same application might work differently under different traffic loads. So seasonality is one thing that needs to be considered when you are trying to optimize, both for performance and at the same time reducing the overspending. And nowadays, with all the advancements in technologies like Kubernetes and all other cloud provider services, we are looking at very rapid application release cycles. So even on an average, even if it is not a microservices, you're looking at around 2 weeks average release cycle. The application behavior changes a lot between these releases. So application with the way that an application worked on version 1 could be totally different how it behaves when it comes to like version 3 or 4. And when it comes to cluster, if you're using some kind of cloud provider, like for example EKS is giving you a bunch of options on the infrastructure side, which is actually a great thing because you have so much options to choose from. But at the same time, it also poses a challenge of picking up the right one. And on top of it, for example, in the case of AWS, you have other choices like, if you want to reduce the cost, you can go with spot instances versus on demand. Spot is used when your application can relive a restart, so there is not much of an impact if an infrastructure goes down. So you have to figure out what is the right place to use these options. Okay, now I've got like a couple of screenshots here. On the bottom left, you're seeing two configurations. They both are horizontal port autoscaler configurations. If you look at the highlighted ones, those are the attributes that needs to be configured on a per application and a per revision basis. So the picture that you're seeing here are the HPA configuration for the same application and the difference between two different versions. So in this case, the metric hasn't changed. We're still looking at the CPU as the metric which is used for HPA. But if you look at the average utilization, that is different because application behavior has already changed. So those are the complexities that you need to look into to make sure you get the best possible combination and to make sure that your application is running well. And the chart that you're seeing on the bottom right, this is actually a representation of the problem that we are trying to solve. So this chart is actually showing the latency of an application under similar traffic workload. On the bottom, the x-axis is actually showing the number of ports that application had when these measurements were recorded. So if you see, the blue line is actually coming down when the number of pods are increasing. So it's actually responding to a scale. So in this case, the traffic is staying pretty much the same. So you can see the latency, the average latency of the application goes down if you throw in more resources. But after a certain point, it really doesn't improve that much. It kind of remains stagnant around like 3.5 milliseconds. But if you can see, the cost associated with more resources is almost linear. It just goes up. The more resources you need, more pods you need, the cost is almost linear there. Now, given the cost budget and the performance SLA, you're actually looking at the shaded area there, and you're trying to find that sweet spot which works best for you. So in this case, the place where is marked as the black one is where you need to be at for this particular application. So you see all the different combinations and the complexity to get it right. So if you don't get it right, all these attributes are going to have a compound effect, both on your application performance and on your cost as well. So just to put the constraints on numbers, so in that example that we talked about, 100 services, and you're trying to deal with both HPA and VPA, because the same application could work, the different applications could work in different ways. So for example, some applications might respond well if you throw in more resources, and some might respond well if you throw in more pods. So it might not work very well if you throw in just more CPU to it. So those two attributes have to be looked at. And next, when it comes to metrics, I'm just going a little conservative here. I'm just putting 3 possible metric combinations. So CPU, memory, and some kind of a performance one. And most applications will have different traffic patterns. So assuming that there are 3 average traffic patterns to deal with and 5 different infrastructure options. Again, it's very conservative here, depending on your cloud provider. For example, if you're using AWS, this number is huge, much, much larger than 5. And considering an average 2 releases per month, you're dealing with around 18,000 different combinations on a monthly basis. So every month you have different combination to deal with to make sure your application is running at the best possible way, both in terms of performance and in terms of cost. Okay, so this is where you see that it is almost impossible to handle this in a manual way. Even if you actually set it up in an automated way, because of all the changes with all the variables, it is almost impossible to get this right. And that is where an autonomous system is going to help you. So let's just go back to those attributes that we discussed on making sure the main aspects that is required to fine tune your application and reduce your cost. Observing metrics. So the challenge there was actually to figure out which metrics to use. An autonomous system should be able to actually connect your monitoring provider, understand your application behavior, and intelligently pick the right metrics. It should be able to identify which metric is representing your application behavior the most. And again, looking at the attributes, looking at how the application behaves on a constant basis, you'll be able to actually figure out thresholds, or you can call it threshold fee, because the free, because it continuously changes, and the system should be able to adapt and figure out what is the right threshold which works. Again, depending on how you take it, it could be considered as threshold free or threshold per application per release. And now that an autonomous system understands an application behavior, it should be able to bring in that intelligence when it is actually time to pick up the right infrastructure. So if you're looking at a cluster, understanding the application behavior, you know exactly what type of applications, what is the individual application need. So that intelligence should be able to be used while we are picking up the infrastructure for the applications. In this case, choosing the right nodes for your cluster. And again, sometimes, as we mentioned earlier, not every application needs the same remediation. If you have a custom remediation that needs to be added, it need not be the same everywhere. So an autonomous system should be able to figure out the right remediation in a given context. So you might see a similar problem happening under two different traffic loads, and the fix could be totally different. An autonomous system should be able to pick up the right fix to fix the problem that you have at hand. And being an autonomous system, we are expecting that system to actually take care of things autonomously. But that doesn't mean that it should just try to do everything by itself. It should notify users when there is a human intervention required. And a few additional things about an autonomous system on top of what we just discussed. Now that we know that an autonomous system should understand an application behavior, it'll be able to predict, provided that once you identify the application behavior, the system should be able to say under different traffic loads or different traffic patterns, how is this application going to behave? Or if you see early indicators, it can predict an issue which is about to happen and proactively fix that before the issue even happens. So if you look at most of the HPA configurations and all, you can definitely fine tune it to be, to be aggressive and make sure it can avoid issues. But in general, it is actually a reactive system. You react after something has happened, as opposed to a proactive system like an autonomous one, which could actually figure out what is going to happen by predicting using machine learning or similar techniques. And of course, when you're looking at an autonomous system which is handling things on behalf of users, you want to have enough rigorous safety checks to make sure that it doesn't break or it doesn't deteriorate an existing system. And another important aspect for any autonomous system is understanding the limitation. So autonomous system can't replace everything. There are certain things an autonomous system can't handle. So we believe that an autonomous system should be inherently safe, in that it should only try to pick up actions that it can execute on an autonomous way. So the first thing an autonomous system should understand is its limitations. There could be enormous situations where things cannot be handled by autonomous system. At this point, we expect the autonomous system to notify the user and let a human intervene. And of course, we expect, when we are expecting an autonomous system to manage your cluster or other systems, we expect to have some configuration capabilities. So when it comes to Kubernetes, we expect the system to have some kind of a configuration where you can set goals at a high level. And of course, since we are expecting the system to take care of the Kubernetes cluster and manage it on a continuous basis, we want to see all these actions, all these effects of the actions to be taken care into the learning and improve as the system goes on. So just want to go through a very high level picture of how an autonomous system could manage availability in Kubernetes or any other cloud provider. So in general, we expect the system to actually connect, understand your topology, probably connecting to your infrastructure provider, or in terms of Kubernetes, it could be connecting to the Kubernetes control plane API, figure out the topology, understand the applications inside it, discover the metrics, correlate the metrics with your application, and then infer the application behavior, understand how the application works. Um, and then once the application behavior is understood, it should be able to predict what is going to happen under different situations. It should be able to understand early indicators from metrics and proactively fix issues for you. And at the same time, sometimes not all predictions are going to figure out the issues going to happen. It should be also be able to detect issues that are happening on a real-time basis and make adjustments accordingly. So when it comes to Kubernetes, a lot of questions that we get about availability is what is that an autonomous system can do. So one of the examples that I can present here is in Kubernetes, if the resource allocation, the limits and the requests that you put in has a huge impact on application performance. Let's say someone has actually allocated lower memory limits than what it is required, then it is quite possible that your application might run into out of memory kills. Or if you have not set the CPU thresholds correctly, there could be throttling happening. So autonomously, the system should be able to identify these issues, reconfigure them so that these kind of issues doesn't happen. And as I mentioned earlier, one of the key things about an autonomous system is you don't want the system to just make the changes and just forget about it. You want the system to keep on monitoring you. If you made an action, if you made a change in your cluster, you want the system to go back and see if that action was really effective. Did it work as intended? Did it have any deterioration effects? If there was a problem, which ideally it should not happen, if there was a problem, it should call for help. If the effect was not as expected, it should be able to adjust its action accordingly using reinforcement learning. So autonomous optimization, the path is going to be very similar to availability management. The first three steps would involve discovering the topology, understanding the application behavior, and then the next steps would be identifying candidates for optimization. And it should be able to safely reconfigure to make sure you get the best benefit. And similar to the availability management, the next thing that it should always do is checking the efficacy of all the actions the system is making. Abort if it thinks that it's not going to work, reset, and include all the learnings that it got from that execution back into its future actions. So these things has to be done when it comes to an autonomous system. All these activities needs to be done on an application per application basis and per release basis. And when it comes to availability management, the whole thing needs to be done on a continuous basis 24/7. Now, that was the basis of how an autonomous system should work. Before I end up a session, I just wanted to go over Sedai. Sedai is an autonomous application management system which is built on all the foundation principles that we just went over earlier. And as I mentioned, at the heart, it is an application management system. It talks to your infrastructure provider or any other APIs available, understand your application behavior, and it tries to make sure your availability at the highest possible level. So the screenshots here show you some recommendations that Sedai is putting out. In this case, it is actually talking about setting the CPU limit, or it is actually seeing high container CPU usage. So you need to adjust the configurations accordingly. And now, Sedai also have a cluster management which takes into account all the inference of the applications, and it brings that intelligence to manage your cluster, making sure the infrastructure that is used is actually the best possible. So in this case, the screenshot that you're seeing on the top is some of the application specific recommendations or autonomous actions that the system has taken. In this case, you can see how much performance improvement the system is able to bring in by just reconfiguring, and the cumulative cost improvement is actually shown at the top. On the bottom, you're seeing a similar recommendation or actions that we are taking at a cluster level. So it brings in that application awareness into the cluster level optimization. One of the principles at Sedai is actually to make sure that we make life easier for its customers, whether it is SREs or whoever uses Sedai. So we want to make sure using Sedai is toil free. It's super simple. So one of the things that we always strive to make sure is onboarding Sedai should be seamless. Using Sedai should be seamless. So we are striving at every possible way to make sure you can easily configure Sedai to monitor your cluster. So if you can see the screenshot, this is actually a screen where you add an AWS account into Sedai, 3 or 4 fields which can be obtained from your EKS system, and Sedai should be able to monitor your Kubernetes cluster. And we know that customers like flexibility. So our approach is actually to be as non-intrusive as possible. So the approach that they are taken is actually connect to your cloud provider, understand your topology, everything using APIs. So we have multiple options. We recommend using the agentless option, where we connect to the Kubernetes control plane API using the network, using a private link, public network, VPC peering. But at the same time, we understand that there are certain security requirements on companies where they do not want to expose APIs over the network, where we have an agent-based solution as well. And as I mentioned earlier, we want our system to be highly configurable. We want the users to be able to set high-level goals, or if you want, fine-tune and specifically configure your applications on an individual workload basis. So you have configuration options available at an account level, an individual application or workload level, or you can create custom groups and set your goals there. And Sedai, similar to how Kubernetes work, will try to make sure your goal is met on a continuous basis. And this is just a high-level architecture of Sedai, which you might have already seen in the previous presentation. It just shows you the different systems that we connect to: cloud providers, monitoring providers, your ticketing system, notification systems, and then if you want to do custom actions, we can also connect to Stackstorm, Runback, where you can customize how your system works. Okay, I think that is pretty much what I wanted to cover. Next, we'll move into the questions. Hello, Dijesh. Hi, Pooja. I think we already have a question. How do you ensure safety while performing any actions with Sedai? Okay, so when we built Sedai, we wanted to make sure the system is inherently safe. So we only act on things which can be safely executed. For example, when we identify there is an availability problem on an application which doesn't have, which is not stateful, which can be like, for example, there is a pod which is behaving totally weird, and it is safe to restart that, we'll go and do it. So inherently, we only pick safe actions. On top of these inherent safe actions, we have multiple safety checks at different levels. So when we are executing an action, we go verify if what we are expecting is what we are seeing on the system, and it is safe to execute every step that we are taking. Okay, I think we are close to our time. I guess there are no other, I don't see any other questions. So, oh, there is one question. I don't know if you have time to take it. How do you identify and populate the right metrics for an application? So for Kubernetes, there are multiple ways. We know the standard metrics which comes out of different monitoring providers. So we have custom integrations with Datadog, New Relic, Prometheus. So we have all the standard ones that we identify. On top of it, We connect to the monitoring provider, fetch all the metrics which are available for all the systems. We try to identify each metrics automatically, but at the same time, if the user has a very custom metric which they want the Sedai to use, they can always come and configure it. Okay, I think we're almost time, so we'll move to the next session, and that's about autonomously improving latency on serverless function. Thank you, everyone.